Okay, good morning, students. Here we just discussed about the IP addressing and the subnetting. Initially, you should know that IP or Internet Protocol is used to identify each computer in the Internet uniquely by this number. So, like we know that our mobile phones, we identify mobile phone number. Similarly, each computer on the Internet will be identified by using this address or this number we call as IP address. So which has two versions, version 4, 32 bits, version 6, 128 bits. Because version 4 is the one we have used earlier, now it is not enough. Therefore, currently we are working the version 6, which has 128 bits. It is similar to our mobile phone number. We know that mobile phone number has 10 digits. Similarly, IP address has version 4, 32, version 6, 128 bits. So if you take now in our A-level syllabus, we discuss only the IP version 4, 32 bits IP addresses. We don't discuss the IP version 6. Now here you are given an example of the IP address normally we represent by binary. So therefore, you know that it is difficult to represent or remember the 32 bits. As a human, it is very difficult to remember the 32 bits. Therefore, we group into 4, including 8 bits for each group. Then 8 into 4, we know 32. Then we can convert that into decimal value. So as given this example, we group into 4 groups like here. This is one group, this is another group, and this is another group, and this is another group. Like then there are 4 groups, 8 into 4, 32. Then we get the corresponding binary decimal value for the binary weight number. So then you get the IP address normally we represent by this format, which is we call as a dotted decimal notation. We separate IP address and the each decimal value and the decimal values be using the dot. Therefore, we call this as a dotted decimal notation. Here it is actually 192.15.0.3. So that is we call as a dotted decimal notation. So then in IP address, if you are given this example here, you can see in the IP address, you can convert 32 bits into 4 groups, each one is 8 bits, and you can convert this to decimal, like in this example, then you will get the corresponding IP address. One thing you should remember in the IP address, the maximum value you can get in the decimal notation is when all the bits are 1. Remember, when all the bits are 1, which is equal to 255. Therefore, in IP address, there can't be a decimal number larger than 255. If you get larger than 255, that is wrong. Just keep in mind. At the same time, if you are given an IP address which is in a decimal, you should be able to divide by 2, convert into binary. Therefore, both ways you must be able to convert from decimal to binary and binary to decimal conversion you should know. But in general, in the internet, we identify each machine using IP address. But the problem is, as a human, we don't like to remember the numbers actually. We forget the numbers. That is why in your mobile phone, all the phone numbers you save by their names actually. That is because of it is very difficult to remember the numbers, but we can remember the names. Now, when you want to call someone, you can't remember that person's number actually, but you can remember that person's name. Because of that concept, in the internet, all the services we represent by a name, not by numbers. These are equal as domain names. In that case, since there are millions of or billions of websites that are having different names, so then there should be a way to make the translation from domain names to IP address. To make the translation from domain names to IP address, you need a special server, which is equal as a domain name server or DNS server. So that is the one which will convert domain names into IP address. Now in a mobile phone, that translation done inside the phone itself, because we have a desktop table where we have saved their names and the numbers. But you can't do that one for the internet, because internet has billions of websites. Therefore, in one place, you can't keep all the domain names and IP address. Therefore, we want to have the distributed system where the DNS servers are located here and there in the world, so that we can connect with the closest DNS server to convert the domain names into IP address. Now, in the internet, in a machine, once you take a computer, in a computer, we identify the computer's IP address. That is uniquely, you can identify each computer's IP address. But once you connect with the computer, remember that computer may have audio, video, animation, images, many documents, many resources are there. Then to identify each resource uniquely, they have defined this URL, Uniform Resource Locator. It's a unique name and name actually which can be used to identify each resource uniquely. You can identify. It can be document, it can be image, like you can identify them using this unique name. So in that case, there are several components that are there inside this URL, Uniform Resource Locator. First part is, as you can see, it is actually protocol HTTP, Hypertext Transfer Protocol. So that's a protocol which is used to transfer the web documents or web HTML tags between the client and the server. So HTTP is a protocol that is used to transfer the HTML tags or web page content between the client and server. It's done by HTTP. That is the first part. Second part is a service. www is a service which is running on the internet. We know this internet is a kind of interconnected or network of networks. On top of that, Tim Berners-Lee developed the World Wide Web. So World Wide Web is a service which is running on the internet. Because of that, you can share all multimedia resources through the internet. So Tim Berners-Lee is the one who developed the World Wide Web, and he is the one who developed the HTML language, and he is the one who developed the protocols HTTP, like many things, web client, web server architecture developed by Tim Berners-Lee to transfer the web contents on top of the internet. So the World Wide Web is a service running on the internet. Then slate.lk is the domain name. Each domain name, there can be top level domain like lk.com, .net, .org, like that is equal as a top level domain. And then other part is a path for the source file or resource file. So this is we call as a uniform resource locator. Then remember, when you take IP address, we can divide into two parts. Every IP address we can do two parts. That is network part and the host part. So network part is used to identify network, because so there are many networks in the internet. Each network can identify the network part. Each machine inside the network you can identify the host part. As you know, in these telephone numbers, when you start the telephone number 0112, we know it's a Colombo area. 055, it's a Badul area. Like you can see, each area you can identify the first part, first three digits. Others are identified each telephone within the given city. Similarly, IP address also first part is used to identify each network. Then within the network, each computer is identified by the host. So as an example, there can be same number in Colombo and the Badulla, but the area code is different. So this area code are similar to identify the network. But within the network, identify the machine can be done by the host part. Then the next important thing is in IP address, the class. Once IP address is given, you must be able to identify what is the class, which is very important. You can see most past papers You cannot do anything if you are unable to find out what is the class of the IP. So then, how do you find the class of the IP? Take the first 8 bits or first part of the IP address. If that number is between 0 to 127, that is class A. If that number is between 120 to 191, it's a class B. If it is between 190 to 223, it's a class C. If it is between 224 to 239, it's a class D. And 240 to 255, class C. That's the way you can identify the class. Then here you can see I have given a set of examples. So 195, then you can see 195 is in the range of class C. 104, class C. 223, class C. This one is invalid. Why? Because I told you in the IP address, the maximum number you can have 255. You can't have IP address number larger than 255. 257 means wrong. 190 means class B. Like when you are given IP address, look at the first part and decide what is a class. Then each class, can you just identify the so now remember each class, the separation of the network part is host part is different. So you need to remember class A, network part we assign 8 bits, host part we assign 24 bits. Therefore, in this network class A category, there will be 2 to the power 8 networks. That means for the entire world, there are only 256 networks in the type of class A. Because each network will get how many IPs? 2 to the power 24 IPs, which is close to 16 million IPs. So that means this IP address of the class A will be utilized by very large organization. Why? Because if someone get a class A IP, that organization will get 16 million IPs. Therefore, it should be used only by very large organization when they need close to 16 million IPs. So then remember class A separation is 8 and 24. Then the class B separation is 16 and 16. So that means class B type, there are 2 to the power 16 networks. That means 65,536 networks. And each networks, you get how many IPs? Again, 65,136 IPs you get for each. Then the class C, 24 and 8. So there will be 24 networks, like it is 16 million networks. And each networks get how many IPs? 256 IPs. This is the one most of the organizations are using in the class C IP because they get 256 IP addresses. So then just remember 3 categories of the class A, B, and C. Remember the class D and E normally reserved for some special purposes. So in general, we use a class A, class B, and class C for public IP addresses. However, if you take the example, let's say there's an organization. This organization has 1,000 computers. In that case, we cannot use a class C because class C IP, you get only 256 IP address, which is not enough. So then, for this organization, how many computers? 1,000 computers. If they have borrowed class C IP, they get only 256 IP address, which is not enough because there are 1,000 computers. However, if they have taken the class B IP, you know that in the class B IP, you are getting 2 to the power 16 IP addresses, which is 65,536. Then you can see which is too large because they need only 1000 IPs, but they are getting 65,536. Then you can see 64,000 wasting. That is the place we can use the other method, which is we call as a classless IP. Classless IP. In this one, how do you use the classless IP to utilize the IPs without wasting? So how do you do that calculation? This is how you should do the calculation. Now for the 1000, you can check what is the closest 2 to the power for the 1000. Then you know that closest 2 to the power 1000 is 2 to the power 10, 1024. That means we should allocate 10 bits for the host and 22 bits for the network. So then because of 2 to the power 10 is 1024, which is less than 1000, so this can be used. Therefore, 10 bits should be allocated for the host, 22 bits should be allocated for the network. But normally we write IP address slash 22. That means network part get how many bits? 22 bits. That's the meaning. So as an example, let's say we have 500 machines. Then how do you identify the network part and the host part? Then, so for that actually, you can let the closest 2 to the power 500 means closest 2 to the power 2 to the power 9. There should be 9 bits for the host, then 23 bits for the network. Like this, you must be able to do the calculation. Then let's say there's organization is 7,000 machines. Then how do I find the network part and host part? This is how you should calculate it. So 7,000 closest 2 to the power is to the power 13, 8,092. Then 13 bits should go to the host, 19 bits go to the network parts. This is the way you should calculate how many bits for the host, how many bits for the network. Then the network mask. Here this network mask is used to identify what's a network and what's a host part in the given IP address. So they have used very simple technique to do this task. What they did was network part, they have assigned 1. Host part, they have assigned 0. Then you can see the class A, 8 bits for the network, 24 bits for the host. So then what they did was they have allocated 1 for the network part, 0 for the host part. Then you can convert this into decimal. Then we know that when all the bits are 1, it is 255. Therefore, class A network mask is 255.0.0.0. That way you can easily find out the network mask. So how to do that? Just keep in mind, network part we assign 1, host part we assign 0. Class B, network part 16 bits we assign 1, host part we assign 0. Therefore, class B network mask is 255 by 0.0. Class C, remember 20 bits for the network, 8 bits for the host. Then we can assign 1 for the 24 bits, 0 for the 8 bits. The network mask is 255, 255.0. That way you can easily calculate the network mask. So then remember for class A, class B, class C, these are the network masks. However, if you take the previous example where there are 500 machines, how do you find the network mask? First of all, you have to find out how many bits for the network, how many bits for the host. Then assign 1 for the network, assign 1 or 0 for the host. So this way you can easily calculate here. 23 bits are 1, 9 bits are 0. Therefore, you can assign 23 bits are 1, 9 bits 0, and convert this into decimal, then you will get 255, 255, 254.0. Like this, you can easily make the calculation. Like if you take this other example, 7001, Then you can see 13 bits for the host, 19 bits for the network. Then you can make 19 bits 1, 13 bits 0. Then it is equal to decimal corresponding value 255, 255, 224.0. So like this, you must be able to calculate network mask. I don't think it's a difficult task. This is another example. If you have 2000 machines, then you can see the closest 2 to the power is 2 to the power 11. So 11 bits for the host, 21 bits for the network. Then you can make 21 bits 1, 11 bits 0. Then convert this into decimal 255, 255, 248. At the same time, you must be able to do the other way. That is, if you are given the network mask, you need to find out how many bits for the network, how many bits for the host. What do? You convert this into binary. Then the ones are representing network, zeros are representing host. Then you can see here 20 bits for the network or 12 bits for the host. Like the reverse calculation can be done like this. Now let's go to the each class. We know that class C IP 24 bits for the network and 8 bits for the host. So remember, this network part is common. It is similar to the LAN phone numbers. We know that all Colombo area will start with 0011, Padul area 055. It is common, it is not changing. Similarly, in IP address also, the network part is common, that doesn't change. What is changing? Only the host part. So in this one, in this IP address, 24 bits are for the network part, which is common. What is varying? Only these 8 bits are varying. So therefore, in this IP address, these 24 bits, that means this part will not be changed. What will be changing? Only the last byte. We know that 1 byte can vary from 0 to 2. Then we know that class C you are getting 256 IPs. Then how do I write all 256 IPs? Remember, all IPs, the 192.45.89 is common. What is changing? Changing is only this part. That will change from 0 to 255. That is how you get 256 IPs. Therefore, when an IP address is given, you must be able to find out what's the class and you must be able to write all the IPs. So therefore, here you get 256 IPs, where the common part is 192.45.89, which is the 24 bits. So then you can see these IPs will be assigned from 0 to 256. Remember, out of these 256 IPs, first one and the last one is reserved. First one is used to identify the network. Last one is called as a broadcast IP. That is, broadcast IP is IP address that can be used to send the message to all the computers in the given network. For that purpose, you can use a broadcast IP. Now in this one, last one is 192.45.89.255. That's the broadcast IP. By using this broadcast IP, there are 254 machines. Those machines can be sent a message at once. So that is we call as a broadcast IP. So first one and the last one is reserved. They are not allocated to the machines inside the network. First one is to identify the network. Last one is to make the broadcasting. So like if you take in this example, this is a class C. So the common part is 200.10.57. Last byte is the one which is going to be changed. It will change from 0 to 255. So then there will be 256 IPs. First one is for the network, last one is for the broadcast. If you take this one, now this is a class B IP. We know that class B IP we allocate 16 bits for the network, 16 bits for the host. Then you are getting how many IPs to the power 16. That means there will be 65,536 IPs. So in this case, the network part is 150 and 25. So then you can see 150 and 25 will not be changed. What is changing? Changing the other bytes 0 and 0. So then you can see you can create IP address like this. Here this part is common. This part is common. Then you can make this one 0 and change the others from 0 to 255. Then you get 256 IPs. Then you can make this one 1 and change this one from 0 to 255. Then altogether 256 IPs. Like this, you can change this one 2 and change the other one from 0 to 255. Similarly, you can continue, then make this one 255 and change the other one from 0 to 56. That is how you get the 65,536 IPs you get, because it's a class B IP address. So this way you should be able to make the calculation. If you look at this example, the first one is class B, class second one is a class B, third one is class C, fourth one is class A, last one is class C. Then you know that class C means separation of the network and host is 21 and 8. Class B 60 and 60. Class C 8 and class A 8 and 24. Class C again 24 and 8. That is how you separate network part and the host part. Then the network mask, you know that class C network mask is 255 to 0. Class B 255 to 0.0, like you can find out it. In the broadcast address, the class C, only the last byte is changing, so the last address is 255. Their broadcast address is 195.34.89.255. Next one is a class B. The common part is 156.10. The other two are varying. The largest value you can give the other two is 255.255. That's a broadcast IP. Third one, class A, we know that only the common part is first byte, that is 17. Then others are changing, varying. The largest value you can get others are 255. Therefore, broadcast IP is 17.255.255.255. Like this, you must be able to make the calculation when the questions are given. So in general, you should remember if the IP address are given with 32 bits, version 4, if you allocate the n bits for the host, there will be 32 minus n for the network part. Then totally how many IPs you get? 2 to the power n IPs. Out of that, the first one and the last one are reserved. Therefore, how many machines can be there, or how many hosts can be in the network? 2 to the power n minus 2. Why minus 2? First one and the last one should be reserved for network part and the broadcasting. The next important is subnetting. Some instance, we want to divide the network into subnetworks. Why do you want to do that? The reason is actually when you make a subnetwork, you can manage that separately. Let's say now if you take a class C IP, now this 195 in class C. So how many IPs you get? 256. So in this case, if I use a broadcast IP, if I send a message, then everyone will get the message, that is 254. All of them are getting the message. But let's say this IP address for some organization that has 4 departments. As an example, there are 4 departments. So in that case, we want to send the message for each department separately, not all together. So for that purpose, we want to divide the network into subnetworks where you can manage it easily. So that's the idea behind subnetworking. So in that one, actually, you can decide how you can divide the network into subnetworks. Now, one methodology is you can divide equally, like you can divide the network into 2 networks, or 4 subnetworks, or 8 subnetworks, you can divide. But if you want same networks, you can divide the subnetworks in different size. That is, one network has the 2 machines, other network has 128, other one has 256, like that. You can have the IPs like that also. So then just remember, you can divide it equal size segments. You can have the variable size segments. Now, in this case, actually, we know it's a class C IP. So in this one, 195.15.89 is a common for all the IPs. So then what we can do is we can define that IP address goes from 0 to 255. There are 256 IPs. Then 256 divided by 4. If you divide this on equal subnetworks, then you are getting 256 divided by 4. Each network gets 64 IPs because 64 into 4 is 256. So in that case, first subnetwork you can assign the IPs from 0 to 63. 0 to 63 means 64 IPs. In the next network, you can assign 64 to 127. Next one, you can assign 120 to 191. The last network, you can assign 192 to 255. So that way, you can assign the IP addresses for each subnetwork with equal size of 64. So in that case, actually, the subnet mask you divide. In that case, actually, we are going to allocate 64 machines for each subnetwork. Therefore, there should be 6 bits for the subnetwork, and the other 2 bits are used to identify the subnet. So then subnet night we get 2 bits, host gets 6 bits. Why host gets 6 bits? Because now we have divided the network into subnetworks, and each subnetwork gets 64 IPs. Then 64 means 2 to the power 6. Therefore, you have to allocate 6 bits for the host and 2 bits for the subnets. The subnet mask will be 6 bits are 0, all the other 26 bits would be 1. Then it is equal to 255, 255, 255, 192 is a subnet mask. Remember earlier we discussed the network mask. This one is a subnet mask. So how do you calculate it? You can find out how many bits are allocated for the subnet ID and how many bits allocate the host based on the way you divide it. So then you can see here the IP address 195.15.89 is common. Then you get the first subnetwork will get the IPs from 0 to 63. Next one get the IPs from 64 to 127. Next one get the IPs from 128 to 191. Last one you'll get the 192 to 255. That is how you allocate each subnetworks. You can see subnet IP, each subnetwork has IP. Starting value is a subnet ID. Last one is a broadcast IP for the given subnetwork. So then you can see subnetwork 1, we have the IPs from 0 to 63. 0 to 63 IP. Then there will be 64 IP. The first one is a subnet IP. Last one is a broadcast IP for the given subnetwork. The broadcast IP is that one. And these were subnetwork 1. Subnetwork 2 start with 64 to 127. The first one is the subnet mask. Last one is the broadcast IP. So that way you can create the subnetworks with the equal size division. So first one will get the 0 to 63. Second one will get the 64 to 127. Third one get the IPs 120 to 191. Last one will get the IPs from 192 to 255. Then altogether each one gets 64 IPs. From that each 64, first one is a subnet IP, last one is a broadcast IP for the given subnetwork. Let's say we divide this network into 8. Remember 8 means 256 divided by 8. In that case, one subnetwork is a 32. Then you can see 32 means 2 to the power 5. 32 means 2 to the power 5. Then you have to allocate 32 IP addresses, which is 2 to the power 5. Then the 5 bits go to the host, remaining 3 bits go to subnetwork. So then you can see subnet mask, only the 5 bits are 0. The others are represented the subnet mask, that is 255, 255, 255, 224. That's the way you need to calculate it. It's not difficult actually, easily and calculate it. So this is an example. You can just go to I share the notes. So in that case, actually, first networks will get from 0 to 31 because there are 32 IPs. Because we divide the network into 8, then 256 divided by 8 is 32. Each network is 32. Then 0 to 31 for the first subnetwork, 32 to 63 second network. Then here the first one is a subnet IP, last one is a broadcast IP for the given subnetwork. The next one, 32 to 63, first one is subnet IP, last one is a broadcast IP. So like this, you can make the calculations. So if you are given this, you can easily calculate it. Now this is a class C IP, 200 means class C IP. We know that in the class C IP, there are 256 IPs. So you want to divide this into 4 subnetworks. When you divide this into 4 subnetworks, 5456 divided by 4, 64. Then you can see each subnetwork gets 64. Then 64 means to the power 6. Therefore, host bits should be allocated 6 bits. The other 2 bits for the subnet ID. So like this, you can see 6 bits should be allocated the host, then 2 bits for the subnet ID. Then you can find the subnet mask by making 26 bits as 1, 6 bits as 0. Then you can calculate the IP addresses. Here you can see we are dividing this into 4 subnetworks. The first subnetwork will get the IPs from 0 to 63. That means 64 IPs. Next one will get the 64 to 127. That is the second network. And next one will get the 128 to 191. Last one will get the 192 to 255. That is how you get the 64 IPs. So first one will get 0 to 63. Second one will get 64 to 127. So like this, you can get the IPs easily. Then the next one is a private IP address range. What are these private addresses? Now, private address actually are used within the organization. Whatever you like, you can use it. That is called the private IP, which is not publicly available for the others. That is for internal purpose. Now, if you take very simple example, now if you take the Sigma Institute, they have a public address. They have put that address on in front of the class. Everyone will know that address and everyone can see this address. People will send the letters to the Sigma Institute using that address which is published. That is called the public address for the institute. But if you go inside the Sigma Institute, there are different rooms, classrooms. The classroom have numbers like 15A, like 15B, so like that 2A, 2B, like you can see there are different numbers. That number is internal purpose. That can be varying according to the organization. So that is we call the private IP. Similarly, for each class that you are using, they have a allocated set of IP address ranges as a private IP address range, which can be utilized whatever you like within the organization. Here, class said that IP address range is 10.0.0 to 10.255.255. Class B, 172.16.0.0, 172.31.255.255. Class C, 192.168.0.0, 192.168.255.255. So like that, we have assigned this private IP address. Just keep in mind these private IPs that can be utilized within the organization, whatever you like. Now, as I told you previously, when you're doing the subnetting, previously exam papers, they give the question in the equal division. But very recent A-level papers, they have done it variable division. That means we don't divide with equal size, multiple sizes. Now, this is how they give the question actually. Let's say there are 4 departments, A, B, and C, D. And each department has a computers, but they are not equal. As shown here, one department has only 10 computers. Other one has 110. Other one has 9. Other one has 27. So then they need some kind of network printers and some of the software servers are necessary. That is for network diagram. Now, in this case, how do you complete this table? That is how to find the network IP, broadcast IP, subnet mask, usable IP address range. Because in this one, you can't divide equally 64, 64, 64 because they need different amount of IPs. Then variable partitioning is necessary. Then how do you do that, which is very easy? Let's see. So what you should do first, look at the given numbers where you have number of computers. Now this one is 10. Find the closest 2 to the power for the 10, that is 16. 110, what's the closest 2 to the power? 128. Okay. And to 9, what is the closest 2 to the power? 16. 27, what is the closest 2 to the power? 32. Then you can see you need to allocate 4 bits for the host, 7 bits for the host, 4 bits for the host, 5 bits for the host. Then you can see 32 minus 4, 28, 32 minus 7, 25, 32 minus 5, 27. So then you can see in the network part, you have to allocate 20 bits are 1, 4 bits are 0. So therefore, you can easily calculate the network marks. We have to make 4 bits are 0. Here you have to make 7 bits are 0. Here we have to make 4 bits are 0. And here 5 bits are 0. Then you can see first one will get how many IPs? 16 IPs. Therefore, network IP is 0, broadcast IP is 15. And this subnet mask, usable IP address range is 1 to 14. This one. And the next one is start from the next address, which is 128 IPs. So that will start from here. This is ended by 15. Next one start from 16. Then you can see 15 plus 128, 143. How do you get this number? Add the 128 for this number. Add the 128 for this number because the connectors get 128 here. So then you can see usable IP address range is 17 to 142. Next one is 144 to 159 because that needs 9 machines, 16 IPs. Then what you should do, add the 16 for the 143. The last one needs 32 IPs. What you should do, add the 16 for the 159. Then you get this. Then you can define usable IP address range. So these are the way current A-level papers questions were given. Please study this. That is the one you will get in the exams most probably. So thank you for joining. I will discuss the past papers with another session. Thank you for joining.